A malicious email has no database password, no send permission, and no shell. But the AI agent reading it might. If that agent mistakes text for authority, a simple summary task can become a data leak. The dangerous object is not just the prompt. It is the path from untrusted content to a privileged action. In the next 4 minutes, you will learn to separate direct from indirect prompt injection, trace a source-to-sink attack chain, and place deterministic gates around an agent. The goal is not to promise perfect prevention. It is to reduce the chance of manipulation and sharply limit what happens when a model gets fooled. Direct injection arrives through the interface. A user tells the model to ignore policy and invoke a restricted tool. Indirect injection hides the instruction inside data the agent retrieves, such as an email, web page, PDF, RAG chunk, tool result, or peer agent message. NIST calls this agent hijacking when malicious instructions and ingested data push an agent toward unintended actions. An unsafe answer alone is not yet the whole incident. Impact needs a reachable capability and enough authority. Follow 4 boxes: untrusted source, model decision, privileged sync, impact. A user asks for an inbox summary. One message manipulates the model, which finds private context and proposes an outbound request. A send, fetch, navigation, image rendering, or API tool becomes the sync. Text with no permissions borrows the agent's permissions. OWASP gives a similar mailbox example enabled by unnecessary send capability. CVE 2025-32711 records AI command injection in Microsoft 365 Copilot that could let an unauthorized network attacker disclose information. It validates a production vulnerability, not confirmed exploitation in the wild. The same mechanism appears in RAG. An attacker-controlled page or poison knowledge item ranks as relevant, enters context, and tries to change the task, leak another tenant's data, or alter memory. Retrieval relevance is not authority. Filter by identity before similarity search and keep provenance and access labels. A signed webhook can carry the same risk. This is a threat model example, not a reported incident. The signature proves transport authenticity and integrity. It does not make a ticket body, commit message, or CRM node safe to authorize a refund or deploy. Schema-validate fields and keep free text away from privileged control paths. A stronger system prompt, model hardening, and classifiers can help, but they remain probabilistic. Google reported that promising static defenses weakened against adaptive attacks and said no model is completely immune. In a NIST-backed public competition, more than 400 participants made over 250,000 attempts against 13 frontier models. Every target had at least one successful hijack. That is not an average failure rate, but better wording still cannot provide deterministic authorization. OWASP maps the entry point to LLM01 prompt injection. Real impact often crosses LLM05 improper output handling, LLM06 excessive agency, and LLM08 vector and embedding weaknesses. Agentic risks also include goal hijack, tool misuse, identity abuse, and memory or context poisoning. Build 6 gates around the model. Ingest, authenticate, validate types and size, and label provenance. Context, authorize retrieval by user and tenant before ranking. Capability, use the smallest type toolset and short-lived credentials. A summarizer should read, not send or delete. Policy, validate each proposed resource, destination, field, amount, and rate. Treat model output as untrusted input, apply egress allowlists and DLP. Action, show a human the exact recipient, data, and consequence for high-impact work, sandbox code, browser, and file operations. Detection, log provenance, tool calls, approvals and denials, rate limit, alert, test complete workflows, and support rollback and a kill switch. The rule is simple: the model proposes, policy code authorizes, a constrained executor acts. Approvals and narrow tools add friction. Aggressive filters can hurt useful work. Use risk-tiered autonomy, harmless reads can flow, while sends, payments, deletes, publishing, and novel destinations face stronger gates. Sandboxing limits machine access, but it cannot stop misuse of an allowed API, so capability and policy controls still matter. Before shipping an agent, ask 3 questions. Can untrusted content reach a tool? Can that tool reach secrets or an external destination? What deterministic control blocks or approves the action? Break that chain, then test it with adaptive attacks. For practical AI agent and cybersecurity training, use the course links in the description.